We have an equation that has an x under the square root symbol and one that's not, so we want to first make sure that our radical is completely isolated so we can get rid of it. And it is, there's nothing outside the radical on this side of the equation to get rid of. So I'm just going to take whatever steps are necessary to get rid of the radical. We, of course, get rid of radicals by using the appropriate power. The power should match the index of that radical, and when there's no number listed, we know it's 2. So I'm going to take both sides to the second power. On the left side, that'll leave us with simply 3x plus 19 because the square and the square root cancel. On the right side, we just have to think back to our Algebra 1 skills of what x plus 3 squared actually means. It means take x plus 3 multiplied by itself, so we're going to do all this kind of rigmarole. And after we do all these x times x times 3, 3 times x, 3 times 3, and combine like terms, we get the expression x squared plus 6x plus 9. As I look at this equation, take a step back, I see I've got some x squareds, I've got some regular old x's, I've got some constants, so it's definitely a quadratic, and that means I need to get one side equal to 0, and I'm going to do my very best to keep the x squared term positive. So I will subtract a 3x from both sides and a 19 from both sides to make this side equal 0, and keep that x squared term positive. It always makes sense to try to line up like terms when you can. So these cancel, and I get 0 on the left equals x squared. These combine to make a positive 3x. These combine to make a negative 10. I have a quadratic. It's going to be factorable, most likely. If you don't like to factor, you can use the quadratic formula. If you can't factor it, you can definitely use quadratic formula. But I can think that x and x would multiply to make x squared. Positive 5 and negative 2 would multiply to make negative 10, and were I to FOIL this out, I would get this x squared plus 3x minus 10 back. So I have x plus 5 times x minus 2 equals 0. That's only true if x plus 5 equals 0, or if x minus 2 equals 0. X plus 5 only equals 0 if x equals negative 5. X minus 2 equals 0 if x equals 2. So my two possible answers are either negative 5 or 2. But because this is a radical equation, I do have to take the step of checking my work and making sure that these actually are answers. We'll start with x equal negative 5 in the original equation. So that would give me the square root of 3 times negative 5 plus 19 equal to negative 5 plus 3. So this left side, 3 times negative 5 is negative 15. Negative 15 plus 19 is going to be positive 4. This right side, negative 5 plus 3 combine to make negative 2. The square root of 4 is 2, so I get 2 equals negative 2. That's not true. Merp. No good. Then we can try the same thing with x equal to 2. I'm going to pause and erase. Now we'll try with x equals to 2. So that gives the left side as the square root of 3 times 2 plus 19 equals 2 plus 3. I'm just plugging in 2 for this value of x and this value of x. 3 times 2 makes 6. 6 plus 19 makes 25. Left side square root of 25. The square root of 25 is 5. The right side becomes simply 2 plus 3. 2 plus 3 is also positive 5. So we get the statement 5 equals 5, which is true. And that means my answer here is x equals 2. Is the only answer that survived the very long process that uses tons of things that you know how to do, but just be careful while you do them, because any misstep along the way causes big problems. So be careful, trust yourself, do a good job, good luck.